Every night, without fail, your mind creates entire worlds. You fall, you fly, you relive old memories, you speak to people who aren't there, you experience fear, joy, confusion, sometimes all within minutes. And yet, you are lying perfectly still in a dark room. Why does the brain do this? Are dreams random noise? Are they messages from the subconscious? Or do they serve a deeper biological purpose? Tonight, we examine why we dream. To understand dreams, we first need to understand sleep. Sleep isn't one single state. It moves in cycles. Roughly every 90 minutes, the brain transitions through stages, from light sleep to deep sleep, and then into something called REM sleep. REM stands for rapid eye movement. During REM, your eyes move beneath closed lids. Your brain activity increases dramatically. Your body becomes temporarily paralyzed. Strangely, brain scans show that REM sleep looks remarkably similar to being awake. The visual cortex lights up. The emotional centers activate. Memory areas become highly engaged. But the logical prefrontal cortex, the part responsible for reasoning and critical thought, becomes less active. This imbalance explains something important. Dreams feel real, but rarely make sense. One of the strongest evidence-backed theories suggests that dreams help consolidate memory. Throughout the day, your brain absorbs enormous amounts of information. During sleep, especially REM sleep, the brain appears to reorganize, sort, and integrate those memories. Studies have shown that people deprived of REM sleep struggle more with learning tasks. Brain regions associated with memory become active during dreaming. Emotional experiences are often replayed or restructured in dream form. In other words, dreaming may be the brain's overnight filing system, but it doesn't replay memories exactly as they happened. It blends them, often into messy montages that make no sense. Another major theory suggests that dreams help regulate emotion. Researchers have observed that highly emotional experiences are more likely to appear in dreams. REM sleep reduces stress hormone levels. People with disrupted REM sleep often experience higher anxiety. Some neuroscientists propose that dreaming allows the brain to revisit emotional events in a safer neurological environment. The chemical profile during REM is different from wakefulness. Stress chemicals like norepinephrine drop significantly, so the brain may be reprocessing emotional experiences, but without the full stress response attached. In this sense, dreams may function as overnight therapy. Now we move into something slightly more evolutionary. The threat simulation theory proposes that dreaming evolved as a survival mechanism. In this view, dreams are a rehearsal space. Many dreams involve being chased, falling, failing, losing control. From an evolutionary standpoint, simulating threats in a safe state may have improved real-world reactions. It's mental training without physical danger. Interestingly, children and adolescents often report more threat-based dreams than adults, which aligns with periods of heightened learning and adaptation. Is this definitive proof? No, but it adds another layer. So, are dreams meaningful? This is where psychology and philosophy often collide. Freud famously believed dreams were disguised expressions of unconscious desires. Modern neuroscience does not fully support this idea. However, it also doesn't dismiss meaning entirely. Dreams are constructed from your memories, your emotions, your fears, your unresolved thoughts. So while dreams may not be coded messages, they are still reflections of your inner world. Dreams often feel strange because they activate emotional centers in the brain. Combine this with active visual imagination, reduced logical reasoning, and suppressed muscle movement, and it's easy to see why they feel so real. The brain is simulating reality without sensory input chuck, and your rational filter is temporarily dimmed. This may explain why lucid dreaming, when you become aware you're dreaming, is rare but possible. In those moments, prefrontal regions briefly reactivate. So why do we dream? The most evidence-supported view today is that dreams are not one single function. They likely serve multiple overlapping roles, including memory consolidation, emotional processing, cognitive integration, and possibly evolutionary rehearsal. Dreaming appears to be a byproduct of a highly active sleeping brain, performing essential maintenance. The imagery may not be the purpose. The processing likely is. Throughout history, dreams have rarely been viewed as meaningless. In ancient Egypt, dreams were believed to be divine messages. In ancient Greece, they were sometimes interpreted in healing temples. In many indigenous cultures, dreams are considered a bridge between the spiritual and physical world. Even today, cultural interpretation shapes how people experience dreams. In some societies, dreaming of ancestors is seen as guidance. In others, recurring dreams may be viewed as warnings or symbolic insights. Modern neuroscience does not support the idea that dreams are external messages, but culture does influence what we dream about and how we respond to those dreams. Studies show that dream content varies depending on environment, stress levels, and social norms. A good example of this is that people living in war zones report more threat-based dreams. Western cultures tend to emphasize personal identity and achievement within dream narratives. This suggests something important. While the biological function of dreaming may be universal, the meaning we assign to dreams is deeply shaped by culture. Dreams may not be supernatural signals, but they are profoundly human. Dreams are not random nonsense, nor are they mystical messages from elsewhere. They are the mind at work, reorganizing, processing, rehearsing, integrating. Every night, your brain performs complex tasks, and dreams are the visible surface of that invisible work. If dreaming serves important cognitive and emotional functions, what happens when sleep is disrupted? Conditions such as insomnia, sleep apnea, and REM sleep behavior disorder can significantly affect dreaming. People with PTSD often experience vivid, recurring nightmares. These are not random dreams. They are tied directly to traumatic memory replay, which reinforces the idea that dreaming is deeply connected to emotional processing. And perhaps most strikingly, people deprived of REM sleep for extended periods often experience mood instability and cognitive decline. The brain appears to require dreaming. This has been Hale Explains, examining the world one question at a time. Don't forget to like and subscribe for more answers.